So once we have the constructor we want to use here, we now have to get values for all the parameters that that constructor needs. So we do that by firstly walking up to the constructor and asking it for its set of parameters. So we get back the parameter array. We then create a parameter instances array, and this parameter instances array will load the values for each of those parameters. We then iterate over all the parameters we've got back from the constructor. We get the type of each parameter, and then if the parameter is either a primitive type or it's a string, we call this helper method called getNonReference parameters. We'll see what that does in a moment. And if it's a parameter that's being configured in our config.json, we call getConfigured parameters. By the time we return from this loop, by the time the loop is finished, the parameter instances array will be full. And it will be full of the values that we want to pass to the constructor when we create it. So we'll take a look at getConfigured parameters first, as that's the easier method. That's actually relatively straightforward. Here, getConfigured parameters, we call resolve to resolve the type that we have. And the resolve method, we're essentially calling recursively. So we end up calling the resolve method here, and that will eventually return some created instance of the type we're trying to resolve. And we add that instance into our list of parameters. The getNonReference parameters is slightly more complex. So getNonReference parameters is here. So when we call getNonReference parameters, we pass in the parameter object, the thing that represents this parameter. And that parameter object will have a type, let's say int or string or double, and it will have a name like age or value. Inside the getNonReference parameters helper, we need to match this parameter against any constructor. And we do that based on the name. So we iterate over all of the constructor parameters. We look at the name of that parameter, and if it matches the name of the parameter passed in, then we can now get the value and store that value as the instance value to pass to the constructor. There's a slight twist, however. So here we can say value equals constructor.getValue, and that gives us back the value we want to use. We know we have a match, so we break out of the loop. However, at this point, the value we get back is essentially a string. It's something we've read out of the JSON file. Once we have that string, we have to convert it to the correct type. And we convert it depending on the type of the parameter that we have. If it's an int parameter, we need to parse the string into an integer. If it's a double parameter, we need to parse the string into a double. If it's a string, we just return the string straight back. So we have some helpers. We have this converters that is a dictionary of these helpers. So converters looks like this. So converters is a map, and it's a map of a class to something of type converter. In fact, we're using one of the new features of Java 8 here. And what we actually pass into here in reality is a reference to a function. And that function is called convert. What that function does is takes a string and returns some type, the type of the actual converter itself. So the idea is the converter might convert a string to an int, or a string to a float, or a string to a double, for example. You might remember back in the constructor, we called this register converters function. And what register converters does is puts into our map the class, so int.class, and the function to be called to convert a string to int, or to convert a double to double. The function to convert a string to a string simply says take that string and return the same string, and the same for char. The function to convert a char to a char simply says take that char and return the char. So back in our getNonReference parameters method, we reach into our converters collection, passing in the class. This gives us back the converter instance, and we can then just call c.convert, pass in the string value, and that will give us back the int or the float or the string or the double, and we add the return value into our parameter instances. So what we now have for a constructor parameter that's a primitive type or a string, we'll have the name of that parameter and the value of that parameter that we can now pass into the constructor. So by the time we've iterated over all of the parameters, we'll have a full parameter instances collection. And the parameter instances collection will either contain the values that we get back from get non-reference parameters, or they'll contain the resolved types we get from get configured parameters. So once we have that, we can create an instance. So here, we declare a variable called instance, and we make it of type T. Remember, T is the type we're going to return from the resolve function. Here, we create the instance, and we'll see that method in a moment. And here, we're currently returning null. We're going to return instance. So create instance needs to take the longest constructor, call new instance on it, passing in the parameters that it needs to for that constructor. So here we declare an object array called parameters, and the length of the object array is the number of parameters this constructor requires. Now what we have to do is iterate over the constructor parameters and the parameter types that we have, match them type for type, assign the values into the object array, and then call get new instance. And this is the code to do that. Now it's fairly simple code. Again, we're not doing any error checking. We're assuming that the first types match. We're not redoing checking based on names here, which is perhaps what we should be doing. But we walk up to the parameter instances one at a time and get the class for the argument. We get the class for the type we want to pass to this constructor. If they are primitives, then we go and grab the value out of the parameters array. If they're not primitives, we get the resolved value. Eventually, we fill in the parameters collection, we call new instance, and we return that instance here. So we are now at the point where we can run our code. So if I go back into Mantizo main here, this is the same code we saw right at the start of this talk. And if I run this, we should get Charlie, Alice, and Bob again, although not necessarily in that order. I've also here written a whole set of tests for this code as well. And if I run the tests from here, then all of those tests should still pass, and indeed they do.